The alternating current is given by the equation I equal to I1 cos omega t plus I2 sin omega t. The RMS current is, options are given. RMS means root mean square. So root mean is the average and square. The currents are I1 and I2. So it is root of I1 square plus I2 square by 2. That means 1 by root 2 into I1 square plus I2 square. Instead of 4, we can write 1 by 2. So the option C is the correct one. If an AC main supply is given to be 220 volt, what would be the average EMF during a positive half cycle? The equation for average EMF is 2E0 by pi or 2V0 by pi. The derivation is given here for reference. So our equation is V average equal to 2V0 by pi. Also, V RMS value equal to V0 divided by root 2. And we can put this in this equation, that is 2 into V0 is root 2 V RMS divided by pi. So just to substitute the value 3.14 and the given value is VRMS, that is 220 volt. So if you substitute, you will get 198. So correct option is 1. If the value of potential in an AC circuit is 10 volt, then the peak value of potential is, options are given. We know the equation for RMS value, VRMS equal to V0 divided by root 2, where V0 is the peak value. So peak value V0 equal to root 2 into VRMS. VRMS value is given, that is 10 volt. Value of potential in an AC circuit, that is VRMS. So we'll get 10 root 2. Option B is the correct one. The maximum value of AC voltage in a circuit is 707 volt. Its RMS value is, we know that VRMS equal to V0 divided by root 2. So it is V0 is given 707 divided by root 2. We know that root 2 is 1.414 or 1 by root 2 is 0.707. So it is 707 into 1 by root 2 is 0.707. When we multiply this, that is 0.7 into 707, we will get almost 500 volt. So option C is the correct one. An AC source is rated 220 volt 50 Hz. The time taken for voltage to change from peak value to 0 is AC voltage. We can draw like this, and the time vary from 0 to T. So from in this question, it is given that time taken for voltage to change from peak value from here to 0 value. That is from T by 4 to T by 2. So change in time is delta T equal to T by 2 minus T by 4. That is T by 4. So we can substitute this one, T divided by 4. In this equation here, frequency is given 50. So frequency is 1 by time. So instead of time, we can write 1 by 50 into 4 is there. So 1 by 200, that is 0.005 seconds, or 5 into 10 raised to minus 3 seconds. An AC source is of 200 divided by root 2 volt 50 hertz. The value of voltage after 1 by 600 seconds from the start is. Equation for voltage is V equal to V0 sine omega t. And here Vrms is given. Vrms we know that V0 divided by root 2. And this value is given as 200 divided by root 2. So here V0 equal to 200 from this equation. We can substitute the value 200 sine omega is 2 pi into frequency 2 pi f. So we can write 2 into pi into f is 50 into time is 1 by 600. It is 200 into sine. If you calculate, you will get it as 5 by 6. That is 200 sine 30. 5 by 6 is sine 30. So it is 200 into 1 by 2, that is 100 volt. So this is the correct thing. A 280 ohm electric bulb is connected to 200 volt electric line. The peak value of current in the bulb is. The options are given. We know IRMS equal to RMS value of current equal to I0 divided by root 2. We have to find out I0. So it is I root 2 into IRMS. Here voltage is given, that is Vrms is given. So we can find out IRMS, that is Vrms divided by, here resistance is given as 280. So it is 200 divided by 280. That is 5 by 7. We can put this value here, that is root 2 into 5 by 7. That will give approximate 1 ampere. So the correct option is about 1 ampere. An AC circuit consists of only an inductor of inductance 2H. If the current is represented by sine wave of amplitude 0.25 ampere and frequency 60 Hz, calculate the effective potential difference across the inductor. Equation for effective potential difference is V effective equal to I effective into inductive reactance XL, or we can write I effective is IRMS into XL. Our IRMS is I0 by root 2 and XL is L omega. I0 is given. We write current as I0 sine omega t. So I0 value is 0.25 is given, that is 0.25 divided by root 2 into L into omega is 2 pi f, 2 pi into frequency, that is 60 is given. So if you calculate, you will get 133.2 volt. Option A is the correct one. An ideal inductor is in turns put across 220 volt 50 hertz and 220 volt 100 hertz supplies. The current flowing through it in the two cases will be. Options are given. Equation for current is I equal to V divided by, it is inductor, so it is inductive reactance XL. That is V divided by XL is L omega, or we can write V divided by L into omega is 2 pi f. That is current is proportional to voltage, directly proportional to voltage and inversely proportional to frequency. Here voltages are same, but frequencies are different. So since the frequencies are different, current will be different. So option B is the correct one. In a circuit containing an inductance of zero resistance, the EMF of applied AC voltage leads the current by. Options are given. In a pure inductor, resistance is zero. So in a pure inductor, voltage leads current by pi by 2 or 90 degrees. So the correct option is 1.